Let's say we have a functional equation f of 4x minus 1 divided by x minus 5, and this is equal to x to the power of 2, and we need to find the f of x. Now I know some people might try solving this by setting the inside to be equal to x, but that's not the right way to solve this. So what we need to do is set the inside function to be equal to any variable, let's say y. So we shall have 4x minus 1 divided by x minus 5, and this is equal to y. And at this point we can cross multiply. So we shall have 4x minus 1 equaling to y times x minus 5, and this will give us 4x minus 1 equaling to, now if we expand this we shall get xy minus 5y. And at this point we can take negative 1 to the right hand side and then bring xy to the left hand side. So we shall have 4x minus xy equaling to negative 5y plus 1. Now on the left hand side, if we pull out x because it is a common factor, for the first part we shall remain with 4, and then for the second part we shall remain with y equaling to negative 5y plus 1. And now we can divide both sides by 4 minus y. This will cancel with that, and so we shall have x equaling to negative 5y plus 1 divided by 4 minus y. And at this point we can multiply this by negative 1 and also multiply the denominator by negative 1. So we shall get x equaling to, now negative 5y times negative 1 will give us positive 5y, and then minus 1 divided by, now negative y will become positive y, and then positive 4 will become negative 4. Now if you remember, we had set the inside of the function to be equal to y. So this will become f of y equaling to x to the power of 2. And we know that x is equal to this. So this will be f of y equaling to, now instead of x we shall write 5y minus 1 divided by y minus 4 raised to the power of 2. So we shall have f of y equaling to, now this can also be written as 5y minus 1 times 5y minus 1 because it's a perfect square, divided by, this is also y minus 4 times y minus 4. And so we shall have f of y equaling to 5y times 5y will give us 25y to the power of 2, and then minus 5y minus 5y, and then plus 1. And this is divided by y times y, which is y to the power of 2, minus 4y, and then minus 4y, and then plus negative 4 times negative 4, which is 16. And so this will give us f of y equaling to, now this will be 25y to the power of 2, and then negative 5y minus 5y, which is negative 10y, plus 1. And this is divided by y to the power of 2 minus 8y plus 16. Now at this point we have f of y, but the problem requires us to find f of x. So what we need to do is replace every y variable with x. So if we replace every y variable with x, we shall have f of x equaling to 25x to the power of 2 minus 10x, and then plus 1 divided by x to the power of 2 minus 8x, and then plus 16, and that's our answer. So this is possible because in math, if you have an equation, let's say a times y to the power of 2 plus by and then plus c equaling to 0, you can write the same equation in terms of a different variable, let's say x. So the same equation can be written as ax to the power of 2 plus bx and then plus c equaling to 0. So these two equations are the same. Therefore, that's how you can solve such a functional equation. If you have found this video helpful, don't forget to like it and also subscribe to my channel. Thank you for watching and have a nice day.